Hey guys, Chase with iDub Hockey, hanging out with Brian Muldner, Director of Engineering for True Hockey. And we have some cutaways of both of your top of the line sticks.
Yep.
For someone who's never really looked into True or really wants to learn about your manufacturing process, let's talk about Axenic and how it differs from the competition.
Okay. Well, first of all, 100% of our sticks are made with the same Axenic technology process, which is basically, it's a compression molded shaft, co-molded with the blade to make a true one-piece stick. So if you look at this cutaway, you won't see any bond joints in the stick. A lot of sticks out there, still specifically lower end sticks, are still made in two pieces. You make a shaft, make a blade, and you'll glue the two together. If you were to take a cutaway of those, you'll see an overlapping joint here toward the bottom of the shaft where the blade and shaft come together. Kind of like a two-piece stick.
Yeah.
It's just bonded together permanently and painted to look like one piece. So all of our sticks from the high-end price point down to the low-end price point are all made with this Axenic process. You don't have to pay for the high-end stick to get that technology.
And so what does the true one-piece Axenic technology offer as an advantage compared to a co-molded or that two-piece style fusion point?
Well, you're eliminating that lap joint, which is going to give you less weight in the bottom of the stick, so that's going to improve your swing weight. You're also reducing what we call stress risers, where those two pieces come together and those walls go from very thick to very thin. That's what we call a stress riser potential failure point. Some of the other companies are now making true one-piece sticks as well. The main difference is with our patented Axenic process, we're the only ones doing it with a compression molded shaft. So what compression molding does with the shaft is it gives you it's a much higher pressure process. We're wrapping materials around a mandrel rather than placing them into a mold and pushing them into the walls of the mold. So our pressure, our cure pressure is 200 psi as opposed to between 100 to 150 psi for a typical bladder molded shaft. Another issue with the bladder molding is that because you have two mold halves that come together, as you cure the material, the resin drops in viscosity as it cures, it hardens. That's where kind of the magic happens. That's where all the layers get consolidated together. As that's happening, as that resin viscosity drops, a lot of that resin can leak out of the mold half, especially if any of that material got pinched out when you close the mold. So with our process, there's zero resin loss. All the resin is fully contained. It's a very high pressure process. We get very consistent laminate quality, very few voids, if any, in the shaft. And the weight consistency, because we maintain all that resin into the shaft, it's far better than any other process.
So if you have a broken True stick and maybe one of your competitors, someone at home could cut open like we have here, and really, I think, would you agree, like one of the best ways to really visualize that would be looking at your shaft wall thickness? Exactly,
yeah. If you cut the shaft like this, you look at the consistent wall thickness, it's unlike a lot of the competition out there where you'll see some wrinkling inside that's created from the bladder. A lot of times you might, if you break another company's stick that's using a bladder molder process, let's say you break it low on the shaft, you've probably seen a little plastic bag inside there.
Right.
That's the bladder. That's what's inflated to push that material out into the mold. And while sometimes it gets removed, usually it breaks off somewhere in the middle of the shaft and it's just left in the shaft.
Right.
So it's a lightweight material, but it does add additional weight that you don't need in the stick. Another problem with those bladders is they tend to leak. They're very, very thin wall. You're pressurizing them with a lot of pressure. If anything is done wrong, if it catches an edge somewhere through the process, you might maintain a slight leak. And now you're specifying 150 psi pressure for your cure cycle. You might be down to 80, 90 psi. You're in a factory making a lot of sticks. There's a lot of noise. Guys can't hear the leaks.
Right.
They open the mold. Stick looks good.
Yeah.
So it goes through the process.
It's just not going to have that true compaction, right?
Exactly, yeah. So as an OEM supplier for 14 years, we used to manufacture for other companies. That was one of the main comments we got, is how much more consistent our weights were, our bending strengths were across the board with our process.
And so the last thing that does tie in with the Axenic technology is the 3K carbon twill. And maybe, can you explain how that's different from a standard 3K carbon?
Well, 3K carbon twill, twill and plane weave, they're very similar weaves. It's just a weave pattern, really. The reason we use 3K as opposed to the more spread toe wider toe weaves that you see out there. If you take an impact, let's say you go in the corner and some guy's skate comes across your stick. If that's a unidirectional material, that material could start to splinter and pull away from the stick. If it's a woven material, and the tighter the weave, the smaller the toe size, like the 3K, you have 8 fibers running in different directions around that one fiber that might have got cut, so it's going to constrain that damage a lot better.
Right, kind of localize it a little bit better rather than letting it run rampant, I guess, right?
Exactly.
Well, Brian, thanks for coming out here and filling us in.
Sure.
And then for you guys at home that would check out more of these true sticks, make sure you go to inlineicewarehouse.com.